Gigabyte have redesigned the Aero 15 laptop and are claiming that this results in 30% better cooling when compared against the older model. So let's put the new Aero to the test and find out just how hot it gets. The new Aero 15 laptop is available in different configurations. My model has the Intel i7-9750H CPU, Nvidia RTX 2070 Max-Q graphics, and 16GB of memory running in dual channel, so expect different results with different specs. It's also available with 8-core overclockable CPU and from GTX 1660 Ti graphics all the way up to RTX 2080 Max-Q. You can find examples and updated prices linked in the description. On the bottom of the laptop, we've got a nice large mesh area towards the back for air intake, while the back rubber feet are sort of angled, which I think may help reduce them sucking the hot exhaust straight back in. Unlike the old Aero, the new model has air exhausts on the left and right hand sides towards the back, along with additional air vents above the keyboard. Otherwise, air is still pulled in through the keyboard too. In terms of heat pipes, we've got more compared to the older Aero, which, as we can see here, just had 2 shared heat pipes. On top of that, Gigabyte have stated that they're using Thermal Grizzly Hydronaut thermal paste, which should hopefully be better than most of the others out there using who knows what. All in all, we're looking at some nice cooling upgrades compared to the older Aero 15, which if you saw my older thermal testing video would severely thermal throttle under these tests. The Gigabyte Control Center software allows us to set the CPU between 5 different levels of power, and the GPU between 2 levels, as defined here. Throughout this testing, I've tested stock settings with the CPU at level 2 and GPU at level 1 with the fans on the normal profile. Here's what the default fan curve of the normal profile looks like. So we're not even getting to 70% max speed and expect it to run warmer but quieter as a result. However, you can of course customize the curve. When testing with maximum fan speed, however, I've boosted the CPU to level 4 and GPU to level 1 for highest levels of performance. So up to 62 watts on the CPU and 90 watts on the GPU. Thermals permitting, of course. Gigabyte also have their AI feature, which basically automatically controls these power limits based on the workload being run. The idea is that you just enable the AI and over time it learns what you do on the machine and then you don't need to go through and constantly change these settings around yourself. Thermal testing was completed in an ambient room temperature of 21 degrees Celsius, so expect different results in different environments. Let's start with the idle results. So the machine is just sitting there doing nothing. With the normal fan profile, the fans were slightly audible, so it's a little cooler, while quiet mode made it completely silent so the temperatures were a bit warmer as a result. These results are from combined CPU and GPU workloads, and are meant to represent worst case scenarios as I ran them for extended periods of time. The gaming results towards the upper half of the graph were tested by playing Watch Dogs 2, as I find it to use a good combination of processor and graphics. The stress test results shown on the lower half of the graph are from running the Ada64 CPU stress test with only the stress CPU option checked, and the Heaven GPU benchmark at max settings at the same time to fully load the system. Let's start with the stress test results. At stock with the normal fan profile, we're thermal throttling on the CPU, and this happens basically anytime the blue CPU bar is at 90 degrees Celsius. When we max out the fan, the CPU is still thermal throttling. However, the GPU lowers back a bit despite now receiving more power, but we'll see in the next graph how clock speeds were affected. By applying a minus 0.18 volt undervolt to the CPU, it's still thermal throttling. And if we instead use a cooling pad with no undervolt, that's still the case. Only when we combine the undervolt with the cooling pad did we finally completely remove thermal throttling under this workload. The gaming tests with thermal throttling on the CPU in a similar manner. However, interestingly, with the AI in use plus maximum fan speed, the CPU temperature dropped down a fair bit. Otherwise, just the CPU undervolt was also enough to remove the thermal throttling with this particular game. And when combined with the cooling pad, we saw quite a large improvement. These are the average clock speeds for the same tests just shown. With the CPU set to the default level 2, we're seeing lower CPU performance, both in the stress test and gaming test. Setting the fan speed to maximum helps boost clock speed as the current limitation is thermal throttling. Interestingly, in the gaming tests, with AI and the fans at default speed, I saw no real difference compared to without AI. However, with the fan at maximum and AI enabled, it was now performing better. Though at the same time, we're getting better performance by just manually setting the CPU to maximum power limit. It's worth remembering that the point of the AI software is to automatically handle these changes for us, so we don't have to go around and manually tweak settings. While it was making an improvement, manually setting things to maximum works out better, but then you'll have to keep controlling these options manually. and leaving the Gigabyte Control Center software open seemed to use about 13% CPU, so you'll want to close it after making manual changes. Almost every time the CPU is undervolted, we're reaching the full 4 GHz all-core turbo boost speed of the i7-9750H CPU, with the one exception being in the stress test without the cooling pad, as it was still just thermal throttling in that instance. That's why we see a 300 MHz improvement with and without the cooling pad in the stress tests. Despite the CPU still thermal throttling at 90 degrees, it's throttling less with the cooling pad. Alright, I know a lot of people in the past have not liked the Gigabyte Aero due to the thermal throttling, and that's fair. However, despite thermal throttling in many of these tests, I think we need to take a step back and compare these results to the older Aero and see how far it's come. These are the clock speeds I got under the same workloads a few months ago when I tested the Aero 15X9 with 8750H and 2070 Max-Q graphics. So pretty similar specs, though I did also test it with a warmer room temperature. At stock, we're 1 GHz behind on the CPU compared to the new model. And even the best case result here with undervolting and cooling pad topped out at 3.3 GHz, which we could easily get in the new model just by increasing fan speed. The old model had no chance of hitting the 3.9 GHz all-core turbo speed in these specific workloads. It was quite far off in fact, while the new one can at least hit the 4 GHz turbo speed with some modifications. Yes, the new Aero still thermal throttles on the CPU under many of these workloads, but you can't argue that these are some great improvements over what they had previously. These are the average TDP values reported by Hardware Info during these same tests. Basically, we can see the CPU and GPU rise up when we increase from CPU level 2 and GPU level 0 in the control center software. These are the average clock speeds while under a CPU-only workload. With AIDA64 and just the stress CPU option checked, I couldn't get the full 4 GHz turbo boost speed even using the highest level 4 option for the CPU available through the control center software. However, undervolting or manually boosting the power limit did allow this to get all the way. This is because it was hitting the 62 watt power limit defined by this mode. So raising the power limit uses more power to hit the 4 GHz clock speed, while undervolting instead requires less power to do so. This reflects in the thermals, where more power equals more heat. We're getting a higher temperature of taking the approach of boosting power limit, whereas undervolting is cooler than using CPU level 2. To demonstrate how this translates into performance, I've got some Cinebench CPU benchmarks here. I haven't bothered testing CPU levels 0 to 3, so down the bottom we're starting with level 4, maximum stock performance using the options available through the control center software. The result wasn't great, however with some modifications we could get very impressive performance. With the power limit boost, Intel XTU was reporting the CPU as running at 100 watts, and it was thermal throttling in this test. Undervolting instead of touching the power limit gave a better score, but when combining the two, a 3100 score was possible. So this just goes to show that we can push the CPU power limit higher manually, which will be useful for intensive CPU workloads. So how do these performance boosts actually translate into games? I've tested Far Cry 5 with the built-in benchmark at 1080p. At the bottom, we've got the default settings the laptop comes with, which is still outperforming the 81 FPS the old Aero with same GPU but 8750H got in this test. The AI mode did actually improve on this. However, it's not going to beat us setting the max CPU and GPU speed through the control center software and manually maxing out the fan. When we undervolt the CPU and boost the power limit, we see the best result. I didn't do GPU overclocking here, as I actually averaged 1 FPS worse performance with it on, as the GPU is always power limit throttled, which is pretty standard with RTX laptops before undervolting. As for the external temperatures where you'll actually be putting your hands, at idle it was in the low 30s in the center, about average. While gaming with the fan at default speed, so not even at 70%, we're reaching the mid 40s in the center. However, the WASD keys are noticeably cooler due to the fan below them. Pretty much the same results with the stress test and fan at normal speed. And then with the fans at maximum, it's not really too different, which isn't surprising as the internal temperatures were the same, as we saw earlier. As for the fan noise produced by the laptop, I'll let you have a listen to some of these tests. At idle with the quiet profile, it was completely silent, while with the normal fan profile, the fans were audible, but it was still quiet. And this is why we saw the different idle temperatures earlier between these two modes. With the normal profile, whether gaming or under stress test, the fan curve makes the fan run at the same speed, which isn't even hitting 70%, so we do at least have the option of making it run quieter at the expense of lower performance. Otherwise, with the fans at maximum, it can get quite loud. However, I think this is a good thing, considering the high level of granularity that Gigabyte are providing through the Control Center software, as it should allow you to customize a sweet spot. Overall, I think these are some nice improvements when compared against the older Aero 15. Yeah, it's still thermal throttles in many of the workloads, but the performance is much improved, and with some undervolting and occasional cooling pad use, thermal throttling could be eliminated. It's worth remembering these tests are meant to be worst case as well. Most people aren't going to be hammering their machine with full load for hours at a time. There are of course other machines with these specs that perform better and don't quite run as hot. But as you've probably heard me talk about in the past, the Aero 15 otherwise has a lot to offer if you're willing to accept this. It's worth mentioning that Gigabyte are limiting the CPU to 90 degrees too. If they did what Dell did in the G5 and let it run up to 100 degrees, then we could get a bit more performance out of it. But personally, I'm happy to take the performance hit and not go above 90. I'm hoping that the new 17-inch model takes advantage of the extra space and has even better cooling. Hopefully I'll get to test it out once it's available. I'd expect the 8-core model to run hotter. However, if you're doing multi-threaded work, the extra 2 cores should still give a nice performance improvement in such workloads. In the future, I think if Gigabyte start undervolting out of the box, like we've seen Acer do in the Helios 300 and Razer do in the Blade Pro 17, then it should be in pretty good shape. Ideally, if the AI software controlled this dynamically with a known stable range, it could make it much more useful. The 230 watt power brick that Gigabyte include with the Aero 15 appears to be adequate for these specs. I was seeing some drain during my testing, but it would stop at around the 95% mark, which is pretty standard behavior. These differences in performance shown aren't hard and fast rules. There are different factors which will vary results. Primarily, the temperature of the room you're running in, application of thermal paste, and even the specific hardware, which comes down to the silicon lottery. You may not be able to undervolt or overclock your hardware the same as me. It depends on the chip and its specific power requirements, so don't just blindly copy my settings and do some testing to find out where your stable point is for best results. It may be possible to further improve temperatures by swapping the thermal paste. However, as this is a review unit that I have to send back, I'm not able to change the paste. Otherwise, the next reviewer will unknowingly report different results due to what I've done. We do at least know they're using somewhat decent paste now anyway. In the past, when I changed the paste on my Aero, I didn't see an improvement, as it looked like the thermal interface material wasn't the bottleneck, but rather the heat pipes and fans. I think this explains why many people trying liquid metal didn't see further improvement. So I'd be very interested to hear how liquid metal goes with the new model. Undervolting, boosting fan speed, or using a cooling pad are much easier for most people to do anyway. And as we've seen, these tweaks did help improve the performance of the new Aero 15 laptop. Let me know what you thought about the thermals from the new Aero 15 laptop down in the comments. Is it still too hot for you, or is the performance boost over the old model a good improvement? If you're new to the channel, you'll definitely want to get subscribed for the full review of the new Gigabyte Aero 15 laptop. It's got a lot of other nice improvements over the old model.